Welcome to Brain Vision.
First of all, let us draw a TS diagram, right? So this is the temperature on y-axis and then S on x-axis. Well, the graph looks like this, right? Well, this is point 1 here. This is point 1. And then this is point 2. Here is point 4, which is not on the graph, and point 3 here. Let's join these points. Okay, this is point 3. Well, this is the TS diagram. All right, now let's do part A. Well, to determine the thermal efficiency, right? And thermal efficiency is represented by mu T. We are doing part A. We will use the given high temperature. Well, high temperature, TH, is equal to 250 degrees centigrade, right? And that is equal to 523 Kelvin. And low temperature is equal to 60.1 degree Celsius, and that is equal to 333.1 Kelvin, right? And now thermal efficiency is equal to 1 minus low temperature divided by high temperature. So we have 1 minus 333.1 divided by 523. So thermal efficiency is equal to 36%. All right, now let us do part B. Now we do part B. Well, to determine the heat rejected, so in this part we find out heat rejected, that is Q out, right? We will need the heat input Q in, so we will need heat input, that is Q in, and the given low temperature TL and the high temperature TH. Well, from the diagram we can see that the heat input is equal to the enthalpy of evaporation at the high temperature. So Q in is equal to HF, and that is equal to 1715 kilojoule per kilogram, right? And we want to find out Q rejected, that is Q out. So Q out is equal to low temperature divided by high temperature multiplied by heat input. And now we plug in values. 333.1 divided by 523 multiplied by Q in, right? Well, Q in 1715, so Q out is equal to 1092 kilojoule. Okay, and now we do part C. Now let us do part C. Well, for the net work output, so we need to find out net work output, W. We need to find out W. Well, W is equal to thermal efficiency times heat input. So net work output is equal to 0.36 multiplied by 1715, and that is equal to 617 kilojoule per kilogram.